Symbol table, error detection and recovery. This is lecture number 4, that is topic number 4 of 6 total. It has 6 topic, in which this one is fourth one, and the lecture number 4 is divided into 3 parts: part A, part B and part C. So this is part A. So in part A we will discuss about the activation trees, that is implementation of simple stack allocation scheme and related to activation tree. So for this purpose, in runtime environment we will see how the stack is allocated. First we will have some introduction. Almost all the compiler for language that use procedure, function or method as a unit of the user defined action manage at least part of their runtime memory as a stack. Each time procedure is called, space for its local variable pushed onto a stack, and when the procedure terminates, that space is popped off the stack. This arrangement allows the following regardless of the sequence of the procedure call. First, memory space is to be shared by procedure call whose duration do not overlap in time. It allows to compile code for a procedure in such a way that relative addresses of its non-local variables are always same. Activation tree. For activation tree, stack allocation would be feasible if procedure call or activation of procedure did not nest in time. The following example illustrates the nesting of the procedure. For nesting of the procedure, we will take one example for the recursive quicksort algorithm. So let us consider we have a read array function that reads the value. It takes the 11 elements and reads the 9 integer value, and 2 spaces for the initial and for the last is used for storing the special value. Partition function just partitions the element from m to n so that m to p minus 1 are less than v, and the pth element is v, and p plus 1 to n should be and the p plus 1 to n are equal or greater than v, and finally it returns p. The quicksort function is simple here. If n is greater than m, obviously m to n we are just applying quicksort here, so we know already all these things. And partition m dot comma n, so partition function will called from here, and the partition value v will be placed in the I, and we apply quicksort from m to I minus 1 and I plus 1 to n, because I is already at the proper place and less than value which is less than I, or the index present, I is the index actually, and the value at value present at this and value present below this index will be less than this value, and the greater value will be at the right hand side. Finally, we have the main function. The main function will call the read array function, and a0 to a10, a0 and a10, these are the two special variable. It takes the smallest value, and a10 stores the greatest value, and we apply the quicksort from 1 comma n. We are just applying this value. So this is the sketch of the quicksort of the program. Now the main function has 3 tasks. It calls read array, sets sentinels, and then call the quicksort on the entire data array. So what it will do, we have a main function, and it will enter to the read array function, then leave the read array function, then call the quicksort 1 comma n. Now enter partition 1 comma 9, leave the partition 1 comma 9, and then it will enter to 1 comma 3 because it is already partitioned 1 to 3. Now leave quicksort 1 comma 3, in between number of steps can be there, and enter the 5 comma 9. These parts are given, then leave quicksort 5 comma 9, and finally 1 comma 9, and then it will leave the main function. So it's very easy to understand. Now this figure is 7.3. so it suggests the sequence of calls might result from the equation of a program. In this execution, the call to partition 1 comma 9 returns 4. Obviously it will return 4. So a1 through a3 holds the element less than chosen by the separator value v, while larger element a5 to a9 stores the greater value. So in this example, the The procedure activates are nested in time. If the activation of procedure P calls to procedure Q, P for partition and Q for quick sort, then the activation of the quick sort Q must end before the activation of partition P can end. So there are three common cases. The first case is that activation of Q terminates normally. Second can be that activation of Q or some procedure Q call either directly or indirectly aborts, that is, it becomes impossible for the execution to continue in this case P ends simultaneously with Q. What happens in this case? It is essentially for so in the first case, the activation of Q terminates normally, then in essentially any language, controls resumes just after the point P at which the call of Q was made. Next, the condition is that the activation of Q terminates because of an exception that Q cannot handle. So procedure P may handle an exception. This is the first point. Second, it can if the P cannot handle the exception. So in these two cases, we have the relevant things here. We can represent the activation of the procedure during the running of an entire program by a tree, and it is called activation tree. Each node corresponds to one activation, and the root is of the activation of the main procedure initiates the execution of the program. At a node for activation of procedure P, we show the activation in order that they are called from left to right. One child must finish before the activation to the right we can begin. So let us take one example, and this was the sequence. And what we can do, we can take R for read array, M for main, P for partition, Q for quick sort for the ease. So this tree is only one possibility. So M is for main, R is for read array, and then Q 1 comma 9 it will be called, and P partition 1 comma 9 will be called. After that quicksort 1 comma 3 will be called, then partition 1 comma 3 will be called, then partition 1 comma 0 will be called, then quicksort 2 comma 3 will be called, then partition 2 comma 3 will be called, then quicksort 2 comma 1 will be called, quicksort 3 comma 3 will be called. Here after this quicksort 5 comma n will be called, 5 comma n partition will be called, either quicksort 5 comma 5 will be called, quicksort 7 comma 9 will be called, 7 comma 9 will be called. So it's very easy to understand how these sequences are going here. So this is the main function, this is the read array, this is the quicksort, this is the partition part, and so on. So this is the activation tree representing calls duration during the execution of quicksort. So it can be compared, these two things, you will understand it very easily.